This week in lab, we'll be doing the standardization of sodium hydroxide. The purpose of this lab is to standardize the solution of sodium hydroxide using the analytical reagent KHP, or potassium hydrogen phthalate. So we'll be determining the concentration of an NaOH solution that we will eventually use to determine the purity of our aspirin that we made a little while back. And remember that concentration is in units of moles per liter. So the whole idea about titration is that you add one reagent to the other until the mole ratio is satisfied, and then that allows you to figure out the concentration of the unknown solution. So you add an acid and a base, and you end with a salt and water. So our acid in this lab is that potassium hydrogen phthalate, and our base in this instance is sodium hydroxide. So our acid will be in the flask that you can see here in this picture. We have our acid, and then we will be titrating our base, and then we'll figure out what concentration our sodium hydroxide is. So the procedure is pretty straightforward. We're going to titrate our KHP solution with the NaOH solution until we reach an endpoint, which I'll talk about in a second. Then we'll record the volume required to titrate to the endpoint and find the molarity of the sodium hydroxide. So when we talk about endpoint, basically as you add the NaOH solution to the KHP, it's going to start to change color because we also add what's called an indicator, which allows the solution to change color when that molar ratio has been satisfied. So the endpoint that we're looking at for this lab that we want it to be is that lighter pink color that I've shown on the slide. And if you've gone past the molar ratio, you've added too much sodium hydroxide, then you'll see a darker color, which I've pointed to in the slide here. So our goal for the endpoint is to be a lighter pink color. So our calculations for this lab, first we'll find the molarity of our KHP solution. So we'll be making a 250 milliliter solution, and to find the molarity of it, we first find the moles based on how many grams we add. Then we can use those moles to find the molarity. So remember, with molarity, the units are liters on the bottom, moles per liter. So you have to change your volume to liters. And in this case, it's 250 milliliters. So change that to liters before you divide. Then we're going to find the moles in each titration. So this is going to be the same. We're going to do 4 different titrations in the video. So it corresponds to 2 from you and 2 from your partner. So in each titration, you're going to have the same amount of moles. So you're using the second calculation here to figure out how many moles are in each of those titrations. So you can do that by multiplying the molarity that you just calculated times the volume of KHP. Remember, again, to turn those milliliters into liters. And it should be the same every time because we're using 20 milliliters every time we titrate. Then, from that balanced equation, you can see at the top, the molar ratio between the NaOH and the potassium hydrogen phthalate is a 1-to-1 ratio. So once you figure out the moles of KHP, now you also know the moles of NaOH because they're the same. So finally, once we know the moles of NaOH, we can figure out the molarity of our NaOH solution by dividing those moles by the volume that it takes to titrate the KHP. So it asks you to use your best volume for this final calculation. And you can think about the best volume is when you saw the lightest pink color. So in the video, if it's a little hard for you to tell what the lightest pink color was, you can take, if the numbers are close together, the volume values, you can take the average of all the values, or you can pick a value that is somewhere in the middle of all of them. Important techniques that you'll see in the video. The first one is quantitative transfer, which means every time we transfer a solution to a different container, we don't want to lose any of that. So we'll be doing things like rinsing the beaker with water just to make sure that any traces of solution left in the beaker are going to go into our new container. And we will be titrating slowly at first to get that lighter pink color, because if we go too fast, we could go past our endpoint and get that darker pink color that I was talking about before. And finally, remember that when reading a burette, the numbers are the opposite of what you would think. So to get the total volume, we subtract the final reading minus the initial reading, and you can figure out how much volume you added. In this video, we are just going to give you the values for the volume, and you don't have to subtract, but just for your knowledge, a burette is read backwards.